This is the second probability lesson where we're looking at calculating probabilities without trees. Okay, so let's jump right in. So we've got a question here saying there is a bag with red and green balls in it. After you pick a ball, you put it back in the bag. You pick out a ball twice. The chance of picking a red ball is 0.4 and the chance of picking a green ball is 0.6. We're asked to find the probability of red then green, and then we're trying to find the probability of both balls being green. Okay, so let's jump right in. So for question A, we're trying to find P of a red ball then a green ball. Okay. Ooh, green. So what that means is we're trying to see what are the odds of picking up a red ball, and then after we put it back, we're going to pick out a green ball. Well, we know the chance of picking out a red ball is 0.4. And remember, if you can imagine, we're going to be going along the branches of a probability tree. Okay, so first a red and then a green ball. Okay, when we go across a probability tree, or when we think of an outcome and another outcome happening after that, we multiply them together. So the chance of a red ball is 0.4 and the chance of a green ball is 0.6. So therefore, the probability of red then green is 0.4 times 0.6. You can use a calculator for this lesson. That will be 0.24. Okay, so that's the answer for A. Part B, the probability of them both being green. Okay, both G for green. Okay, and what this is basically asking us is probability of green and then green. So the probability of picking a green ball is 0.6, and the probability of picking a green ball after that will also be 0.6 because we put the balls back after we take them out. So using a calculator, or if you know this off the top of your head, 0.6 times 0.6 is equal to 0.36. Okay. Let's answer to part B. So we're just doing the same questions now, but we're just not using a probability tree to answer these. Let's have a look at another example. Mike is playing 2 games of chess with his friend. The chance of him winning his first game is 1/3. The chance of him winning his second game is 3/4. Okay. So we're going to find the probability he wins both games, the probability he loses both games. Okay. So probability win both. And that's going to be equal to, we're going to say win 1. We're going to call this first outcome win 1, meaning he wins the first game, and then the second one is he win 2, meaning he wins the second game. Okay. Now this is important because he has different probabilities for winning his first game and his second game. Okay. So the probability of him winning his first game is 1/3. And then if he goes on to win the second game, we know the probability is 3/4. So multiply by 3/4. Multiply the fractions. 1 times 3 is 3. 3 times 4 is 12. We're not happy with that. Sorry, 3/12. We need to simplify this to 1/4. Okay, so that's the chance of him winning both games. Okay, and if we think about the second one now, part B, what are the chances that he loses both? Okay, now you need to remember all probabilities need to add up to 1. Okay, so we're going to do lose. He loses round 1 and then he loses round 2. So if the chance of him winning the first game is 1/3, then the chance of him losing has to be 2/3 because all outcomes have to add up to 1. He either wins or he loses. He could draw, but we're gonna ignore that for now. So there's a 2/3 chance of him losing. And what's the chance of him losing the second game? Well, is a 3/4 chance of him winning the second game. So that must mean he's got a 1/4 chance of losing it. Okay. So multiply the fractions. 2 times 1 is 2. 3 times 4 is 12. Simplify the fraction. That will give you 1/6. Okay. That's your final answer for that one. Let's have a look at another example. Okay, so on the next example now. There is a bag with purple and yellow balls in it. After you pick a ball, you put it back in the bag. You pick out a ball, or you pick a ball up twice. Okay. The chance of picking up a purple ball is 0.3, and the chance of picking up a yellow ball is 0.7. Find probability of yellow then purple. And then we're going to find at least one yellow ball. So we've got a neat little trick we can use for question B, okay? But for now, part A, as we've done before, P of yellow then purple. So we're just going to do Y and then P for purple. The chance of picking a yellow ball is 0.7. Lovely. And then we're going to pick out a purple ball. And the chance of, yellow, then, yellow is 0.7, purple is 0.3. 0.7 times 0.3 is 0.21. Job done. Easy peasy. Now, B, slightly different, okay? I'm going to show you a little trick for solving quite difficult questions, okay? So we need to find the probability of at least one yellow ball, okay? So probability at least one yellow. Okay, at least one Y. Let's call it one Y. So if you think back to the probability trees, if we had the probability trees like so, and then we had yellow and purple, and then we had yellow, purple, yellow, purple. Okay, the outcomes of these were yellow, 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 purple, purple, yellow, and purple, purple. Okay, so how many of these outcomes have at least one yellow ball? We got the first one, second one, and the third one. Okay, so the only one that doesn't have at least one yellow is when we pick two purples. Okay, now all of these numbers, all of these probability outcomes, they have to add up to 1. Okay, so for this question, we can either calculate the probability of yellow, yellow, probability of yellow, purple, the probability of purple, yellow, and add them all together, or we can find the probability of purple, purple, take this away from 1, and we will have found the sum of all the others without working out anything else, okay? And you can test this in your own time if you don't believe me. It absolutely works. But I'm just going to do it very quickly now, just to show you how easy it is to find these seemingly difficult questions, okay? So instead of finding the probability of at least one yellow, we're going to find the probability, we're going to do 1 take away probability of no Y, no yellow, okay? That's going to be equal to 1 take away, and the probability of no yellow has to be purple, purple, okay? So 1 take away P of purple, purple equals 1 take away, a purple is 0.3, 0.3 times 0.3. Let's start going down the page. 1 take away 0.09, and that is going to equal 1 take away 0.09 is 0.91. Okay, and there you go. There we have found the probability of at least one yellow, because we've done 1 take away the probability of no yellow. So this 0.91 is all the other outcomes added together. So white, yellow, yellow, purple, yellow, yellow, purple, all these are 0.91, sorry. And the probability of 2 purples is 0.09. And if you add those together, you get 1. So that's how we can use this little trick for finding at least one item if you do things 2 or 3 times in a row. Okay, nice little trick there. And you see that later on in the questions. Let's have a look at another example. Mike plays a game of snooker with a friend. His chance of winning game is always 2/3. Find the probability that he wins all 3 games. Find the probability he wins at least 1 game. So hopefully we should start to be getting the hang of this now. So he wins all 3, and that is going to equal probability of win, win, win. And there's going to be 2/3 times 2/3 times 2/3. 2 times 2 times 2. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Can't simplify that. 8 over 27. That's the chance of him winning all 3 games. Part B. Now we've got this wins at least 1 game again. We've got a little sneaky one here. So P wins at least 1. 1, okay. Now, we could either figure out the probability of him winning two, winning all three, winning the first and the last one, or we can use our little trick of 1 minus probability of loses all games. Okay, if you did that, so we can find 1 of P, L, 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 lose, equals 1 minus chance of him losing is a third, so a third times a third times a third. 1 take away a third times a third times a third is 1 over 27. So 1 take away 1 over 27, well, we could think of 1 as 27 over 27, and that would leave us with 26 over 27. Okay, so we've turned potentially quite a difficult question to a much easier one, okay, by finding the outcome of the only outcome which isn't the one we're looking for and taking that away from 1. Okay, so those are your examples. Here comes the main task. So pause the video, read the questions carefully, and have a go at these questions, okay? Best of luck. And here are the answers for the questions. Very well done if you got those all right. And just be careful when you're doing these probability questions, make sure you're doing it step by step. Don't try to rush it because it's really easy to make an honest mistake with these questions. Okay, so make sure you write out all your steps, what probabilities you're finding out. Okay, and hopefully that'll reduce the amount of mistakes you make. Okay, let's have a look at the checking question now. James, Fred, and Kevin each take a penalty. The probability James scores is 4 out of 5. Probability Fred scores is 2/3. And the probability Kevin scores is 3/4. What is the probability of all 3 scoring and at least 2 boys score? Okay, so pause the video and have a go at this question. Okay, so let's have a look at this now. So probability of all 3 scoring. So probability of all 3 scoring, that's going to be the probability of, so let's I'm going to use this annotation, this convention. So if I say JFK, that means they've scored. But if I say J dash, F dash, and K dash, or K prime, sorry, I should be calling those, that means they miss. Okay, so if you see a J, if you just see the letters JFK, you know they've scored. If you see a J with a dash, an F with a dash, or a K with a dash, you know they've missed. Okay, so first one, we're trying to find the probability of them all scoring. So J, probability of J scoring, then F scoring, then K scoring. Well, we've got them, all their scores up there, and we're just going to multiply them all together. So 4 over 5 times 2 over 3 times 3 over 4. And if you do all those, you should get 24 over 60. And if you simplify that, you should get 2 over 5. Job done. First one's nice and easy. Now, the second one is where it gets tricky, okay? Now, unfortunately, you weren't able to use the nice little trick that I showed you earlier in the lesson of 1 takeaway, because that only works for at least 1. If it was at least 1 boy scoring, feel free to use it. But unfortunately, it's not quite that simple. Okay, so first of all, let's think about what outcomes we can have where at least 2 boys score. Okay, well, they could all score. So J, F, K, they could all score there. Okay, or let's write J, F, and then Kevin could miss, but still 2 have scored, but Kevin's missed. We could do J. We could say Fred missed, but Kevin scored. And we could say that James missed and the other 2 scored. Okay. And if you wanted to, so then to solve these, all you do is multiply the probabilities together. So the chance of them all scoring, well, we've got that. It ended up being 24 over 60. Okay. Now I'm going to leave it as 24 over 60, and you'll see for why now. The chance of James and Fred scoring, but Kevin not. So that's going to be 4 over 5 times 2 over 3 times chance of Kevin scoring was 3 over 4. So there's a quarter chance that he misses. And if you figured out that, you would get a score of 8 over 60. The next one, so only Fred does a score. So James scores, that's 4 out of 5. Fred misses, so that's going to be a third, because there was a 2/3 chance of him hitting. And Kevin scoring is 3/4. So the chance of this happening is 12/60. And the final one, what is the chance that only James misses? Well, it's going to be a 5th chance of him missing. And then 2/3 for Fred, and then 3/4 for Kevin. Multiply them together, that gives you 6/60. Okay, so these are the outcomes of at least 2 boys scoring, okay? So the probability of at least 2 boys scoring, of at least 2 score, at least. So in this case, once now we've found out the individual probabilities, it's going to be J, F, K plus, so we're going to be adding, now we're going to add all these probabilities up, okay? So I'm just going to write JFK plus PJFK. It's a lot of writing for these. PJFK. The first one, they all score. The second one, Kevin misses, then Fred misses, and then James misses, okay? So now we need to add all these up. So the more scoring was 24/60. Kevin misses, that was 8/60. And then Fred missing, that was 12/60. And James missing, that was 6/60. Okay. And if you added all those up, so 24 plus 8 is 32, plus 12, 44, plus 6, 50, you should get 50/60. And you can simplify that to 5/6. And that was the probability of at least 2 of the boys scoring in their games, okay? So very well done if you got that last one. There's a lot of working out and you weren't able to use a little trick for it, okay? But if you did get 5/6 because you thought about all the different outcomes, very well done, okay? And we'll see you next lesson. Bye now.